My concept was good enough to win the bid, but the design isn't finished. Now it's time to get things ready for fabrication. First, I'll document the required welds. Next, I'll connect the new frame to the existing one, add glass guarding and sensors to all the openings, and I'm sure Andrew, our analyst, will have something to say. He has a tendency of recommending last-minute changes. Before I forget, I'm going to temporarily subscribe to Andrew's PDM activity so I can keep an eye on his progress and jump on any changes he recommends right away. I'll start by adding the weld beads to the structure. I can specify the exact type and location of every weld bead in the design. Best of all, once I add the first weld bead, the Smart Weld Selection tool helps me quickly apply similar welds. I can also apply mass, cost, and time properties, tally up the totals, and account for these calculations downstream. I need to design a bracket to connect my assembly to the main structure. Problem is, the top level assembly is really big, and I just don't want to deal with any unnecessary slowdowns. Fortunately, the envelope publisher lets me reference the components I need from the top level assembly and insert them into the sub-assembly without taking a performance hit or affecting the assembly's mass or bill of material. Sheet metal design has historically been a specialized skill, but in SOLIDWORKS, it's as easy as creating an extrude feature right in context of the assembly. Convert to Sheet Metal wraps a layer of sheet metal around the extrusion, automatically adding ripped edges and all the manufacturing details like corner styles and auto reliefs. And I might as well kick out a DXF flat pattern so the shop can get a head start. With a right click, I can generate the pattern, and I can even filter the bend lines and other features to separate layers, so the DXF file can go straight to our laser cutter. Tedious tasks are a part of every design. For this project, it's the glass guarding. So boring and time consuming, but using the right tool for the job will speed things up. I could start by converting individual entities and extending and trimming, but with silhouette entities, I can get the exact profile I need on the first try. This tool is also great for work cell footprints in plant floor layouts. With the custom-sized glass panel created, I could use standard hardware to mount it. This is where things really get fast. As soon as I drag this hardware into the assembly, it's mated in place. And because these components will always require the same mounting holes and fasteners, I can insert those automatically using smart components. Whew! It used to take me forever to do this kind of stuff. Ah, Andrew. Let's see what he came up with. Okay, it looks like I'm gonna have to make some modifications to the frame and the linkages. And wait, swap out the motors too? So it appears I've over-engineered the frame and he's recommending thinner walled square tubing. That'd require purchasing new materials versus using what we already have in stock. Way too costly. I'll have to ignore that one, but Andrew does his research, so I'm sure the rest of his recommendations will save us cost and optimize the design. First up is to locate the arm in the right position. Remember, the frame was based on a simple extrusion, so if I edit the height dimension, everything else will update. Next, I'll slide the pick and place over to the proper offset and tweak a couple overall length dimensions on these links. Andrew also mentioned we can get away with lighter duty servo motors. These new servos are coming from the same supplier, so this should be an easy swap. Dang it! These face IDs don't match up perfectly. But fortunately, Replace Components guides me through reconnecting the existing mates to the new faces, making this last-minute assembly modification a breeze. I'm nearly done, but our electrical engineer JP is counting on me to add the appropriate safety sensors. I'll use mate references and smart components again to make this task a snap. That all took way less time than I expected. I added the necessary annotations for fabrication, designed a sheet metal bracket, added a bunch of new components, quickly adapted to Andrew's recommendations, and gave JP a heads up about the updates he'll need to make to his electrical schematics. As a result, a quick rerun of our costing analysis shows we're still within budget. SOLIDWORKS has a ton of features that can speed up common tasks, making design changes nothing to be afraid of.